Hi, grade 10s. Welcome to the lesson on quadratic formula, discriminant, and interpreting roots. So the previous lesson, we looked at using the inverted, using graphs, and using factoring in order to solve quadratic relations. In this lesson, we're going to be looking at something called the quadratic formula to help us solve quadratic relations and equations. So the roots of a quadratic equation are its x-intercepts, also known as its zeros. Solving a quadratic equation means to determine its x-intercept. So again, we're looking for those x-intercepts. That's the important thing that we're looking for. Well, many quadratic equations cannot be solved by factoring. The roots of all quadratic equations in the form of ax plus bx plus c equals 0 can be determined by the quadratic formula. So if you're ever encountering an equation where you're looking at and you can't figure out how to factor, this is the way you can always find it as long as a does not equal 0. Because if a equals 0, it's not a quadratic function. So the quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac over 2a. This is what we call the quadratic formula. This is going to help you find the roots of a quadratic relation no matter what. It's going to tell you whether or not there are any zeros, anything like that. So how do we go about doing this? Quadratic equations are solved differently than linear equations, which are all solved by isolating a variable. There's two methods to solving quadratic equations written in standard form. The first one we've already started working on. That is factoring. It's more efficient in many cases because it doesn't work if the roots are irrational, meaning it doesn't work if the roots are some crazy numbers. Factoring can only determine rational roots. However, the quadratic formula, which is what we're going to be working with today, works in every single situation where the roots exist. This is the caveat. The roots need to exist, meaning that there needs to actually be a root. It has to go through the x-axis. So what we're going to do is a couple examples. I'm going to write down some examples here. The rest you'll find in the document that is a complete lesson with the homework answers. So looking at the first one here, we have 3 bracket x squared plus 3x plus 6 equals 0. The first thing we need to do is make sure that it is in standard form. Right now it is not, so we need to distribute that 3 in. So then we get 3x squared plus 9x plus 6 equals 0. Okay, that's standard form. We're good. What we should always start with doing when we are looking at quadratic formulas is to identify what our A, our B, and our C is. In this case, our A is our 3, our B is our 9, and our C is represented by 6. Next, always write out the quadratic formula, which is x equals negative b plus minus the square root of b squared minus 4ac, and this is all over 2a. Our next step is to sub in the information that we know. So we end up getting negative 9 plus minus the square root of 9 squared minus 4 times by 3 times by 6 all over 2 times by 3. So what we're going to do is start solving inside the square root. So we get negative 9 plus minus the square root of 81 minus 72. 72 is what 4 times 3 times 6 equals, all over 6. Next line, let's fill in the rest of the bracket. We get minus 9 plus or minus the square root of 9 over 6. So what you're going to notice here is we have plus minus, meaning that there's going to be two possible answers. So at this point, what we want to do is draw a line going one way, a line going the other. We're going to now separate the two possible answers, where either the square root of 9 is positive or the square root of 9 is negative. The reason being is we could have a negative times a negative giving us this square root, or a positive and a positive giving us our square root. So we get negative 9 plus the square root of 9, which is 3, over 6. The other side, we have negative 9 minus 3 over 6. Let's start with finishing up this one first. Got negative 9 plus 3 gives us negative 6, which is negative 6 over 6, gives us negative 1. And on the other side, we get negative 9 minus 3 gives us negative 12 over 6, which then gives us negative 2. So what we can know now from this is that these are our two roots. So therefore, x equals negative 1 and x equals negative 2. The answer to this one will be up on the lessons completed document, but let's try another one, a little bit harder one. C will also be up on the document. Let's look at this guy, because this one's a little bit different. So what we want to do is first put it in our standard formula. So we have 3 equals x squared minus 2 minus 10 equals 0. And we have 3x squared minus 12 equals 0. What's different about this one? Well, the main part that's different about this one than the others is that we don't have a b. So when we're filling out what our a, b, and c are, we're going to put 0 where b is. We have 3 where a is, and negative 12 where c is. We can still do this. This will still work. It's just going to look a little bit different. So we have our x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Let's fill it in. We got 0 plus minus the square root of 0 minus 4 bracket 3 bracket negative 12. And this is over 2 bracket 3. So this gives us the square plus minus the square root of negative 4 times by 3 times by 12, negative 12. This is going to give us positive 144. And this is all over 6. Now we're going to break off again, just like we did with the other example. And we get positive 12 divided by 6, and we get negative 12 divided by 6. And this gives us positive 2 and negative 2. We could have seen at this point that this was factorable. If we take out the 3, we get x squared minus 4. And this, you would have noticed, is one of our special cases of a difference of squares. But if you don't notice it right away, you can just use the quadratic formula and go straight to it. This question here is an application one. It's a word problem. It's going to take us through a couple more steps, and it's going to bring back something that you guys probably wish stuck in a corner, aka substitution. We're going to be applying the ideas of linear systems now to quadratics. A rectangular field is going to be completely enclosed by 100 meters of fencing. So this is how much fencing they have to enclose the entire field. Create a quadratic relation that shows how the area of the field will depend on its width. Then determine the dimensions of the field that will result in an area. So here's the important part, the area of 575 meters squared. Round your answers to the nearest 100 meters of length. Nearest hundredth of a meter. What we're going to start by doing is create two equations to help us eliminate the L that would have normally been there. Right now we have two information. This here, our 100 meters, is our perimeter. So we know that P equals 100 meters. Now our perimeter is equal to 2L plus 2W. So what we can do here is take this away, and we found our first equation here. 100 equals 2L plus 2W. We've created our first equation. Now we need to create our second equation. If you guys remember, area is equal to length times width. So in this case, we can say 575 meters is equal to L times W. Okay, so we have two equations. This is looking a little familiar. It kind of looks like substitution. So our first stage that we always do, first step, when we have any sort of linear system, is to isolate a variable and get rid of one. So that's what we're going to start by doing. It asks us in the equation to make a quadratic equation that will depend on its width. So in order to get an equation that just has a W, we're going to start by isolating L in equation 1. So we're going to isolate L. So when we're isolating L, we go from 100 equals 2L plus 2W. We're going to move the W to the other side, so the 100 minus 2W equals 2L. Now we need to get rid of the 2, just have L by itself. We divide by 2 on both sides, and we get 50 minus W equals L. So that's our first part. The next thing we want to do is sub L into our second question. This will start to get us the quadratic formula that we're looking. Let's see how that ends up happening. So we have sub L into 2. So our original equation was 575 minus L times W. So once we sub in L, we get 575 bracket 50 minus W, and we're still multiplying it by W. When we multiply this out, what we get is 50W minus W squared. This sort of looks like a quadratic equation, but it is not in standard form. Anytime we use the quadratic formula, we need to put it in standard form. So that's what we're going to do next. Put into standard form. And how we do that is we make it equal to 0. So we have 575 equals 50W minus W squared. And we're going to make it equal to 0, bring the 575 over to the other side, but we also want to rewrite it in the correct order. So our square comes first, so negative W squared plus 50W minus our C value, which is our 575. At this point, what we need to do is find what our W's could be. And how we're going to do that is by using the quadratic formula. So we're just going to head on up here. So we're going to find W. And the first thing we want to do is state what our A, our B, and our C equal to. Our A is negative 1, our B is positive 50, and our C is negative 575. I'm getting that from right down here. This is our A, B, and C. Next thing we want to do is we want to write out what the quadratic formula is. So it's negative b plus minus the square root of b squared minus 4ac all over 2a. And what we're going to do is sub in our information. So we get negative 50 plus minus the square root of 50 squared minus 4 bracket negative 1 bracket negative 575 all over 2 negative 1. So what we're going to start doing is solving the square root. Get negative 50 plus minus square root of the square of 50, which is 2500, minus negative 4 times by negative 1 times by negative 575, which gives us negative 3200. And this is all over negative 2. What we're going to do now is bring the information together inside the square root, plus minus the square root of 200, it's getting smaller now, all over negative 2. Now we're going to break off. We're going to have plus on this side. Get plus square root of 200 is 14.14 approximately, so all over negative 2. And then on our other one, we're going to do the negative of the square root of 200, so we get negative 50 subtract 14.14 all over negative 2. This will give us our W1 of 32.07 and our W2 of 17.93. So here's the thing with these ones. It's asking us for a dimension here. Round your answers to the nearest 100th of a meter. So these are our 100ths of a meter. One thing to note is the width can either be this or this, which means whatever the width is not is what the length is going to be. So what we're just going to write is a little therefore statement. And we're just going to say therefore the dimensions are, because we could have the width and length exchange pretty one-to-one, so we don't need to worry about that. So therefore the dimensions are 32.07 meters and 17.93 meters. So backing out here, the steps that we did was bring the information together and create two equations, one of each. We isolated one variable and subbed it into the other equation. Once we did it, what we end up getting was a quadratic relation. We put that quadratic relation into standard form and then use the quadratic formula to solve for the actual dimensions. Now, the examples that we've done so far are examples where we have two real roots. That's not always going to be the case. Sometimes we can have one root, no roots, or two roots. Let's look at some examples. Looking at these equations here, you're going to notice that there are a certain amount of roots that are possible, a certain amount of zeros. So if we're looking at the red one first, y equals x squared plus 4x plus 3, we'll notice that there are two zeros. What are the roots? So they are negative 3 and 0 and negative 1 and 0. Looking at the next one, which is the dotted, the dash blue, x squared plus 4x plus 4. That gives us just one root, and that's negative 2 and 0. Now, looking at the purple dot, you have x squared plus 4x plus 5. There are no zeros. So this is NA. Investigating here, we have an equation. Y equals 3x squared minus 5x plus 9. We can either graph it or use the quadratic formula in order to find it. But since we don't feel like graphing, we're going to use a quadratic formula and see what happens. Let's see if we can find the roots for this one. Our A is 3, our B is negative 5, and our C is plus 9. So x equals negative b plus minus the square root of b squared minus 4ac over 2a. Let's put in our information. Get negative 5 into the negative b spot. That's going to give us positive 5 plus minus square root of negative 5 squared minus 4 bracket 3 bracket 9 all over 2 bracket 3. Let's start bringing this information together. We got 5 plus minus the square root of 25 minus 108 all over 6. 5 plus minus the square root of negative 83 over 6. Wait a minute. Negative 83. This isn't going to work. You can't have a negative square root. A negative square root is impossible because a negative and a negative will give us a positive, and a positive and a positive gives us a positive. There's no way to get a negative number and multiplying it by itself. So we can't have negative square roots, the square root of a negative number. It just can't happen. So that's a lot of work to get to the point where we realize there are no zeros. There's got to be an easier way to check. Hooray, there is. So yes, there is an easier way we can check. We can simply look at the stuff, yes, the stuff under the square root of the quadratic formula. Mathematicians call this the discriminant. So if b squared minus 4ac is less than 0, so that means a negative number, there's no real roots. If b squared minus 4ac is greater than 0, then there's 2 real roots. Now, if it equals to 0, there's only 1. That's when the vertex is on the line. So here are our different examples of different roots that we could have. Again, I'm not going to show you every single example here. The answers for all of them will be on the document, but let's look at a couple ones here. Let's start off with 1. So how we're going to do this is very similar to if we were starting to do a quadratic formula, is we're going to identify our a, b, and c. Our a is 9, our b is negative 5, and our c is 2. And instead of writing the full thing, we're just going to have an equal sign of b squared minus 4ac. This is the stuff underneath the square root. This is our discriminant. So we're going to plug in the numbers that we have. So we're going to have negative 5 squared minus 4 bracket 9 bracket 2. So will give us 25 minus 72, which gives us negative 47. And since this is a negative, we can say therefore there are no zeros. Therefore, no zeros. Let's look at another example. Let's try 2 now. So we have a equals 3, b equals plus 10, and c equals negative 2. So we got b squared minus 4ac. We plug into the information we have, so we have 10 squared minus 4 bracket 3 bracket negative 2. This gives us 100 plus minus 4 bracket 3 bracket negative 2 So we get 100 minus 12 plus 24, which gives us 124. So we see this, we can say therefore there are 2 roots. Let's try another one. 3 will be up on the document, but let's try 4. So our A is 9, our B is negative 12, and our C is 4. We get equals B squared minus 4AC. So we get 12 squared minus 4 bracket 9 bracket 4. This will give us 144 minus 144, which gives us 0. Therefore, there is 1 root. Pretty straightforward and to the point. We're going to try one more, and this one's just a bit more complicated because there's a few more steps, just because the equation is a bit more complicated. Let's look at this guy here. Yeah, okay, well, we got a bunch of information here, but this is not in standard form. So we need to get this to standard form. We're going to expand and move things around. So let's start off by expanding this bracket here. So what we end up getting is 2x squared minus 8x plus 9x squared equals 3x minus 1. We're going to bring some stuff over and collect some like terms. So we get 11x squared. We bring the 9x squared plus 2x squared. 3x comes to the other side, which makes it a negative. So negative x plus negative 3 gives us negative 11x. And that negative 1's coming over to the other side, positive, and this equals 0. Now that we have this, it's in standard form, it's nice, we can investigate how many roots are. And we're going to start off by identifying our A, B, and C. Our A is 11, our B is negative 11, and our C is positive 1. So let's put this stuff in. We got B squared minus 4AC. We get negative 11 squared minus 4 bracket 11 bracket 1. What we get, oh, I made a mistake up here, guys. Notice here, that should have been 3. This is a 3. Remember always, guys, check your signs, make sure you're distributing properly. Let's just fix this. Excellent. All right. So what we end up getting is 121 minus 132, which gives us negative 12. Therefore, since this is negative, there are no roots. 6 will be up in the document with the completed lesson afterwards. Here are some lovely practice questions for you to try out. Obviously, keep trying them out, see if you're getting it. If you're feeling confident, you can move on to the homework. So inside work here, some homework for you to work on. All of these. Remember, if you have any questions on any of them that you're having trouble understanding, put a star next to them and bring them to class next day, and we can go over any questions that you have. All right, have a good day, guys.